Thank you for the opportunity to speak today about intermittent fasting. My name is Lisa Hayes. I'm an endocrinologist at Advent Health Endocrinology. I'm also one of the medical directors there. And today I am talking about intermittent fasting, which is more than just a fad diet. So this topic became interesting to me because I was hearing patients ask about it a lot, and about the time that patients were asking about it, the New England Journal of Medicine also produced a major review article in-depth reviewing intermittent fasting. And so I became more interested in it at that time. And that was about the time that we were looking for people to speak for the LIV conference. So it all worked out well. Before we start, let's talk about what intermittent fasting is. So it's a way of limiting the amount of caloric intake in the day so that we can change how our body processes calories and generates energy. Let's review the objectives that we'll cover today. First, I want you all to understand the common types of intermittent fasting. Then we'll review carbohydrate and fat processing in the body, just a basic biology review. Then we'll discuss some of the benefits of intermittent fasting on metabolism and cardiovascular system and the brain. Finally, we'll discuss some of the potential side effects of intermittent fasting and why intermittent fasting may not be for everybody. And then we're going to explore the ways to start intermittent fasting. This slide really hits home right now with COVID and everyone spending all their time in front of the computer doing Zoom meetings and watching LIV conferences. But you can see at times we used to be much more mobile. We have evolved over time to being much more sedentary, and this has really affected our metabolism. The way we eat has also evolved. For 2 million years, we were hunter-gatherers. We never knew where our next meal was going to be, and there was no guarantee we were going to have a meal within the same day. Many times we'd go days without eating. And then agricultural societies developed, and that allowed for regular meals to be consumed. Now the societal norm is that we have 3 meals every day, breakfast, lunch, and dinner. And God forbid you skip one of those meals, you get the wrath of your parents, right? The amount of calories that we consume has also increased in recent years. You can see on this slide pictures of what a typical cheeseburger at McDonald's used to be like and what a typical hamburger is out to eat now, where it's almost twice as many calories. My favorite example on this slide is the soda. I can remember when it was a treat once a week to have a soda at my grandparents' house on Sundays, and that was 8 ounces. Now we have a soda every day and it's 20 ounces in size. It's considerably more calories. And you can see the other examples here on the slide as well. We all are aware that the prevalence of obesity is dramatically increasing through the last couple of years. This is a slide that is commonly shown from the Center for Disease Control. Yes, they do things other than just COVID. And they were tracking the incidence of obesity in various states. This slide was from 2011, and you can see the orange states are states that have obesity rates where above 30 to 35% of their patients, of their population have obesity. And we can go forward, we can see that the occurrence of obesity is increasing. Now we're having, in 2013, 2 states that have over 35% of their population with obesity. And we can see as we advance in 2015, more and more of those states are starting to show up as having obesity. In 2017, more red, and in 2018, the last year that the data was reported. And just to review for everyone, obesity is measured by body mass index, which is your weight divided by your height squared. And normal BMI or body mass index is 20 to 25. Obesity is 30 and above, and severe obesity is considered a BMI of 40 and above. So why is it bad to have obesity? Well, obesity increases our risk of other health complications, mainly diabetes and cardiovascular disease. Diabetes is the #1 cause of amputations in the United States, #1 cause of blindness, #1 cause of kidney failure along with high blood pressure, which leads to the need for dialysis or kidney transplant. So diabetes has a great financial impact on our economy as well as individual impact on our health. As we said, it increases the risk of cardiovascular disease. Most people aren't aware that obesity also increases the risk of cancer. Particularly in women, there's a higher risk associated with breast cancer, endometrial cancer, that's the same thing as uterine cancer, and ovarian cancer. Women who are obese are more likely to have a condition called polycystic ovarian syndrome, where they get cysts on their ovaries and they don't ovulate regularly. So the lining of the uterus builds up, and that puts them at a higher risk of uterine cancer or endometrial cancer. Beyond those health effects, there's other health effects as well from obesity, including arthritis, neurologic effects like stroke and dementia, that means memory loss, and depression. People with obesity have a higher risk of osteoarthritis in their knees and in their hips, and that can increase the risk of needing joint replacements, which can be quite painful and have a lengthy recovery. Let's get into what is intermittent fasting then. Basically, intermittent fasting is a way of limiting our food intake to change how our body processes calories and generates energy. And there's two main thoughts of intermittent fasting. One is limiting the time that we eat during the day, and the other is limiting the calories that we consume during the day. Before we get into specifics about metabolism, I thought it would be nice just to do a general overview. Just kidding. This slide is quite complex, but what we would need to know about is, I'll break it down this simple. Our body takes in sugar or carbohydrates, and we convert that in our cells into energy in the form of ATP. That's typically how our body is fueled, and how we generate energy to make our muscles work, our organs work, our brain work. Just to review for everyone what a carbohydrate is. Carbohydrates are anything such as fruits and vegetables, grains, basically anything that comes from a plant is a carbohydrate. Also, there's some carbohydrates in dairy foods as well. Sometimes people confuse carbohydrates and cholesterol, so just to make sure everyone understands what a carbohydrate is compared to cholesterol. Cholesterol is a fat. And that's typically found in animal products or oils, nuts, eggs, that type of thing. So what happens when we fast? When we're not taking in food, we're not consuming sugar, our body has to burn something else to make energy. And basically what our body does is takes triglycerides from fats and converts those into fatty acids, which are then broken down in the liver into ketone bodies. And our body can actually use these ketones as a fuel source to make our brain work when we're not eating. When we don't eat, ketone bodies start to rise. So after about 8 to 12 hours of not eating or of fasting, our ketone levels start to rise. Excess food intake prevents our body from generating ketones, and so it makes it less likely that we're going to have high ketone levels when we overeat. Our brain can use these ketones as a fuel source when we're not eating. This process of changing from burning carbohydrates to generating ketones as a fuel source is called the metabolic switch. And the metabolic switch is pretty much the heart of the benefits of intermittent fasting. And we'll talk more about some of the hormonal and protein benefits that happen when we undergo the metabolic switch. So scientists now understand that when we fast and we generate these ketones, our body actually uses these ketones as signaling proteins or molecules that have many health benefits. They seem to have a benefit on our overall health as well as anti-aging. I'm not going to expect you all to remember all these proteins that get stimulated when we fast, but the one at the end, the brain-derived neurotrophic factor, is the one that I find really fascinating, and we'll talk more about how fasting has a neurologic benefit on our brains. We now understand that with intermittent fasting, those ketone bodies and the metabolic switch signal to our body an antioxidant effect that actually stimulates the removal of damaged proteins. These damaged proteins may have some cancer effects, and so by intermittent fasting, it's hypothesized that we're actually stimulating the removal of these damaged DNA, which may have some anti-cancer effects. We also know that intermittent fasting decreases inflammation in the body as well. We now understand that the benefits to intermittent fasting go beyond just the calorie restriction that happens with limiting food intake. When we compare the results of studies looking at individuals who had just calorie restriction or if they had calorie restriction through intermittent fasting. There's actually better improvements in waist circumference with intermittent fasting compared to just calorie restriction diets. And there's also improvements in lower insulin levels when people eat after they've been intermittently fasting compared to just caloric restriction. And we all know the ill effects of abdominal obesity and that waist circumference. And we'll talk more about how that influences metabolic syndrome. So there are basically three main types of intermittent fasting for dieting. The first is time-restricted fasting. The second is the 5-2 method. And then the third is alternate day fasting. I personally feel that the time-restricted fasting is probably the easiest to get into. And this is the concept of limiting our caloric intake to a compressed time during the day, usually between 4 to 10 hours of the day. So having our first meal, if we're going to do, say, 6 hours of time-restricted eating during the day, having our first meal around noon, having our last meal finish at 6 p.m., and not eating in between that time period, after that time period. That is the most popular type, and like I said, the easiest to get into. And we'll talk later in the talk about how to get into intermittent fasting. The second most common method is the 5-2 method. And this is where basically you eat a normal diet 5 days of the week, and then 2 days of the week you're gonna fast or take in less than 500 calories for 2 days of the week. And then the third option is what most people would say is alternate day fasting, where you eat a normal 3 meals a day, snacks as much as you want, eat after hours, etc. And then every other day, you're going to severely restrict to 500 to 700 calories per day. All with that idea of the time period that you're not eating or taking in less calories, that you're going to be triggering ketosis and that metabolic switch. So what are the benefits of intermittent fasting? Well, we talked a little bit about this earlier, but just to review, it seems that there's some anti-inflammatory effect and decreased oxidative stress with intermittent fasting that seems to be triggered by those ketone bodies being generated. It also increases DNA repair, which may have some anti-cancer effects. In animals, we have strong studies showing that animals who are food restricted or fasted have some anti-aging properties and seem to live longer than animals who are overfed. And in humans, we know that when we intermittently fast in athletes, that there seems to be improved endurance results with long distance running, etc. Well, let's dive into some of the benefits in the cardiovascular system. Studies show that with intermittent fasting, we can actually decrease our total cholesterol as well as decrease our LDL cholesterol. That's the bad cholesterol. I always remember that by LDL, L meaning lousy. And then we can also decrease our triglyceride level, and it lowers our blood pressure and our heart rate as well. Studies showing that intermittent fasting reduces the risk of diabetes and as well reducing our risk of metabolic syndrome. And we know that diabetes and metabolic syndrome are both associated with a higher risk of heart disease. So I'm sure you're all asking, what's metabolic syndrome? Metabolic syndrome is basically 5 health conditions that we now know are associated with a higher risk of cardiovascular disease and diabetes. To qualify as having metabolic syndrome, you have to have 3 of the 5 conditions. So the 5 conditions are, number 1, high blood pressure, and that's typically a blood pressure of 140/90 untreated, or if you're having to take medicines to keep your blood pressure under 140/90. The second component is a low HDL. HDL is the healthy cholesterol, so we don't want a low cholesterol here. And if your HDL is less than 50, then that's associated with a higher risk of metabolic syndrome and heart disease. The third component is high triglycerides, which is a triglyceride level above 150. The fourth is a high waist circumference or abdominal obesity. And then the fifth component is a high glucose, and that can be either a high fasting glucose or diabetes or prediabetes. Sometimes doctors will talk about something called the Hemoglobin A1C, and that is a 3-month average of what your blood sugars have been. It measures how much sugar is attached to our red blood cells in our body. Red blood cells typically last 90 days, and we can measure in the lab how much sugar is attached to those red blood cells, and that gives us a rolling average of how your blood sugars have been. So A normal hemoglobin A1C is 5.7% or less. Pre-diabetes is a hemoglobin A1C of 5.7 to 6.5%. And then diabetes is an A1C of 6.5% and above. So for metabolic syndrome, having a hemoglobin A1C of 5.7 and above meets one of the criteria for metabolic syndrome. And if you have 3 of those 5, then we say you have metabolic syndrome. And that helps your doctor recognize whether you're at risk of developing diabetes or heart disease. We know that there are benefits with intermittent fasting to diabetes. Studies actually show that when we have diabetic patients do intermittent fasting, we can actually improve their insulin resistance, meaning their body responds better to the insulin that they produce themselves. We also have shown that our body doesn't have to make as much insulin, and we know that high insulin levels in our own body are associated with higher inflammation levels. Individuals who do intermittent fasting tend to have better blood sugar levels 2 hours after a meal compared to people who are not doing intermittent fasting. And we also know that there's some benefits to weight loss with intermittent fasting as well, which the less weight you have, the less insulin resistance you have, and the better your diabetes will be able to be controlled. The thing we have to be careful with people with intermittent fasting and who have diabetes is they may be on some medications like insulin or sulfonylureas that can cause them to have low blood sugars if they decrease how much calories they take in. Sulfonylureas are medicines you may have heard of like glipizide, glyburide, or glimepiride. So in individuals who are thinking about doing intermittent fasting who have diabetes, I always want to caution them that they need to be making sure they're monitoring their blood sugar more, both fasting and before meals and throughout the day. And they may need to think about using a continuous glucose monitor, such as a Dexcom or a Freestyle Libre. I included some pictures of those so that individuals could understand what we're talking about here. The green image is the picture of a Dexcom, and the other one is a Libre. The Dexcom is usually worn on the abdomen, and the Libre is usually worn on the arm. And they basically measure the blood sugar every couple of minutes, and they can alert a patient if their blood sugar level is going too low without even having to poke their finger. Let's switch gears and talk about some of the neurologic benefits of intermittent fasting. We now know that neurologically, intermittent fasting seems to trigger, through the metabolic switch, the production of a hormone called brain-derived neurotrophic factor, or BDNF. And basically this protein or hormone allows our bodies and our brains to adapt better to change. It allows us to better tolerate insults or injuries to the brain through like head traumas, strokes, and allows our brain to adapt and change in time. In animals, we know that intermittent fasting has been shown to improve their balance and their coordination, improve their spatial relations, basically how well they can run through those little mazes we see them doing in science experiments. It also has been shown to decrease the effects of strokes, and also in animals, it seems to decrease the progression to Alzheimer's disease when we give them Alzheimer's disease. In humans, we also know there's some neurologic benefits as well. It seems to improve our metabolic syndrome, and metabolic syndrome is a risk factor for strokes as well as dementia and memory loss. We also know that neurologically, individuals who do intermittent fasting have improved balance and coordination. And in older adults, there's studies showing that intermittent fasting improves verbal memory, executive function, and global cognition. One study looking at 2 years of restricting calories in humans showed that those who restricted calories through intermittent fasting had an improvement in their working memory. It may also protect their brains against damage during chemotherapy. So individuals who have brain tumors who are undergoing chemotherapy treatment, and we really want just the chemotherapy to kill off the cells in the brain tumors, not damage the rest of the cells in the brain. Intermittent fasting seems to have some brain protective effect against the healthy tissue in the brain that we don't want damaged from chemotherapy. We also know that intermittent fasting tends to help adults recover faster when they've had a stroke, and that's probably through that brain-derived neurotrophic factor benefit. So as we say in life, nothing is free. We always have to be careful with any new therapy that we try. And there can be some concerns with intermittent fasting. So the first thing I always recommend again is to make sure that you're not at risk of hypoglycemia. Particularly people with diabetes who are on certain medications should make sure that they talk to their doctor, make sure their doctor is aware that they're going to try intermittent fasting, so the doctor can counsel them on how to adjust their medications to prevent low blood sugars. Anytime we restrict calories, we can put ourselves at risk of protein malnutrition, and that can cause difficulty of poor healing wounds, lead us to more risk of broken bones, etc. So make sure that you're getting adequate protein even if you're restricting the time in which you're eating. People are also at risk of dehydration from intermittent fasting. When we have ketones in our body, they tend to make us urinate more frequently, and we can easily get dehydrated. That can cause us to feel dizzy or nauseated. It can also cause difficulty with sleeping or syncope, passing out. It can cause falls, migraines, headaches, weakness, as well as causing hunger pains. I have to tell you all that I have tried intermittent fasting a couple of different times, and I always struggle to get over the hunger pains. So how I have done it in my own life is on weekends where I don't have any obligations in the morning, I'll try and put off my first meal of the day to expand that time period in which it's been since I've last had my meal. So who should not try intermittent fasting? We tend not to want people who are pregnant or breastfeeding to restrict calories in any way. They're supporting lives, and we need to make sure that they're getting adequate nutrition to support those other lives. We tend not to recommend intermittent fasting to the frail or the elderly. They're already at risk of dehydration and falls, and we should not exacerbate that. We tend not to recommend any type of caloric restriction to children, and those with a history of eating disorder. People with eating disorders tend to have some obsessive compulsive thoughts around foods to begin with, and we can really trigger that by putting caloric restrictions in place or time restricted restrictions in place, and that can tend to trigger eating disorders to flare. And then the last individuals that we want to be careful of is traumatic brain injuries. They may already be at risk of malnutrition or dehydration, and that's probably not the appropriate person to think about using intermittent fasting on. Before starting any diet, we want to make sure that we talk with our doctor and make sure that we're okay to start intermittent fasting. So let's talk about how to get into time-restricted feeding. So this is one example that I saw published, and I thought it was a nice way to break the ice as far as intermittent fasting. So the first concept would be the first week, for 10 hours of the day, you're going to restrict your eating 5 days per week. So for those 5 days, the first meal, we're going to start at 8 a.m. and we're going to finish our eating by 6 p.m. So that would be a total of 10 hours of eating during the day and 14 hours of not eating. Then the next week, we're going to crunch that time a little bit more. So we're going to restrict our eating to 8 hours of the day for 5 days of the week, and the other 2 days of the week just eat normal 3 meals a day. So our first meal of the day would be at 10 a.m. and we'd finish by 6 p.m. So that would be 8 hours of eating. Then the following week, we would restrict to 6 hours per day for 5 days of the week. So our first meal would be at noon, and then we'd finish eating by 6 p.m. And then the last week would then be where we're just restricting to 6 hours of eating, starting at noon, finishing at 6 p.m. for 7 days of the week. So that's one way to break the ice and get into time-restricted feeding. Say we decided we wanted to do the 5-2 regimen. So 6 days of the week we eat normally how we would like to eat to our own hunger. And then 1 day of the week we're going to restrict our calories to 1,000 calories. Then the next week we'll restrict calories to 1,000 calories 2 days out of the week, and the other 5 days of the week just eat normally. Then the following week we'll do 750 calories for 2 days of the week, and then eat normally all the other days of the week. And then finally 2 days of the week we'll do 500 calories the following week, and all the other days just eat normally. So in conclusion, we've talked about some of the benefits of intermittent fasting and how that likely is related to the metabolic switch, and it goes beyond just our calorie restriction. Intermittent fasting has been shown to trigger that metabolic switch that triggers the production of ketones, and those ketones seem to stimulate other proteins in our body that have those beneficial effects on our heart, our diabetes, our neurologic effects, as well as endurance, etc. Gradually reducing the time frame of eating is an easy way to get into intermittent fasting. We definitely need more research to understand the benefits of intermittent fasting. I feel like we've just really scratched the surface to see some of those benefits. And probably some of the benefits are going to be long-term. So it's going to take a long time to get that scientific data to show the benefits doing years of intermittent fasting. As we talked about, intermittent fasting isn't for everyone, and there can be some negative effects. So we need to make sure that we're talking to our doctor before we start any intermittent fasting regimen or any type of diet. Here are some of the references that I pulled from for my presentation. If you are interested in intermittent fasting and want to talk with your doctor about it, the New England Journal of Medicine article from 2019, it was published in December of 2019, was really a great talking point for you and your doctor. Like I said, I found it very informational, and it really got me interested in learning more about the subject of intermittent fasting. Thank you for listening to my talk today.